Assalamu alaikum. This video is also about anomalies, modification anomalies, in which we explained them in the previous videos as insert anomalies and update anomalies and delete anomalies. As a reminder of the definition of anomalies, anomalies is a situation when you experience in the database a situation that if you would like to insert some records in a table, you are forced to insert other records that might not be needed or available. And also this definition applied to the update anomalies, in which we are required to make multiple updates in the same table, especially if the table has a lot of records that if there is a change in the database, then the same update must be done multiple times, which it results in inconvenience and time consuming, and also it might be prone to errors, as sometimes we might enter the information incorrect, so it will result in data inconsistency. And regarding the delete anomalies, also the situation when you delete a record, you lose some important information that are important for the database. Let me explain this in respect of this table here. First, I would like to talk about insert anomalies. An insert anomaly occurs when certain attributes cannot be inserted into the database without the presence of other attributes. For example, this is the converse of a delete anomaly. We cannot add a new course unless we have at least one student enrolled on the course. Look at this data here. I have some students. You see their names, their numbers, and their addresses. Each student is registered in some courses. Some students, like Jones here, is registered in 3 different courses. He is registered in course number 9201 and 9267 and 9268. He had the same student number S21, 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 but he is registered in 3 different courses. That is accounts and database and also web design. Okay. This table you see here is not normalized. We call it unnormalized data, which many information concerning students and courses all in one single container, in one single pocket. Situation which is not convenient. It results in inconsistency, and also it results in unintegrity of the database. Insert anomalies. Let me give you a practical example of insert anomaly. Why we said you cannot add some information without the presence of other attributes. Like what? For example, the college decided to add one more course. Say would like to add English course with course number 9999. Okay, I would like to put it here. Can I add a course here without registering a student? I mean, I can add a course to this table. Of course, practically I can do it, but you will see that here there is no anybody registered on it. Why it will see this is empty. I have this table here in exist here in my database. So if I would like to insert a course, like insert into students, and I would like to insert course number and course, which is course title, of course, values. I said I would like to insert this 1999 and as English. Alright, so let me see what happens. It will be inserted. Let me select all from select all from this table and see what happens. You will see that here this information is missing. There is no students registered for this course. So the course is added, but there is empty information here. So this one will result in such a situation where you will see that some information are missing because you inserted a course without a student. There is no students registered for it. So insert anomaly is a situation when you cannot add a course without adding a student. So I can actually make up any student here and register him for this course, even though there is no student registered in the course. So I have to force a student to register in the course so that I can actually add it. Practically you can do it, but as you see that you'll see your database in a situation of inconsistency. Regarding the let me delete this course. Delete from students where course num equal 9999. So I would like to delete this course and have this same data that I had before. Alright, so simply insert anomaly is when you have to insert something. You cannot insert something without the presence of other information on this side. So even if there is no student, then you have to add a student in order to register this course, especially if there is a primary key here. If there is a primary key here, of course we were able to do it here because there is no primary key for this non-normalized data. But if you have a primary key for this normalized data, we cannot even do it. It is not possible to do it because it will ask you to add student number, because student number, for example, is a primary key. It's just in this example, the student number is not a primary key because it is repeated many times, because Jones here is registered in many courses and also Richard. So in a situation when a course where a table has a primary key, you cannot add this course without adding a student for this course. Alright, so now let us go to update anomaly and explain it. In update anomaly, it exists when one or more data is updated. For example, if you look at Jones here, if Jones, for example, moved to another address, so I would like to remove this Edinburgh and change it to, for example, both or London or something. So Edinburgh here is 3 times. Assume that there are 7 courses that Jones registered, so his address will appear 7 times here. So I have to actually make a lot of changes, and this also applied here for course name if the course title is changed. So I have to also make for example, if the course is repeated here in this example, I have given this example in this table here, where you see actually computing computing 3 times. So if I would like to actually change this to computer 1, so I have to make multiple change many times. If also Edinburgh has changed, this John has changed his address, so I have to make his change here in this address many times. You see here, Edinburgh appears here, it appears here, and it appears here 3 times, and also computing. So update anomaly simply when you make multiple updates, and this is time consuming and also prone to errors, as I said before. For the delete anomaly, it exists when certain attributes are lost because of the deletion of other attributes. So for example, if you consider this student number, for example, this student Richard, he just dropped the course. He would like to drop the course. He would like to drop the semester. So both courses, computing and math, will be dropped, because if you'd like to delete Richard, how do you delete Richard? You delete Richard by his student number. So delete student number S30. So S30 is deleted. These 2 records will be deleted. You will lose a fact that we have a course called computing and we have a course called math. So both courses will be removed from our database. So we lose some important information in our table. Okay, so this is anomalies, which is not situation that is required in the database, and we said we need to avoid it by what? By making normalization. Let me just talk a little bit about how we can fix this problem. Okay, this is non-normalized data that you have seen here in my table, this table here. I just put it here to show you how we can actually fix this through normalization process. So what kind of dependency that you see here? I see here if you look here on this side, you will see that there's transitive dependency. Why? Because a non-key attribute, which is course number, determines another attribute. Like what? Like if you know the course number, you will know the course title. So if the course number is 9201, for example, then this course is called computing. Here it is. It occurs here, it occurs here, and it occurs here. And also 9267. If 9267 here, the course is called database. You'll see it also here. 9267 is database. So this course number determine course. So I can actually divide this table into 2 by having the course information in one table and student information in one table. So kind of dividing this non-normalized data into 2 courses. I would like to call the first one student info and the second one courses, such that the student info contains only information about students, which is student number, student name, and address, and the courses table contains only information about courses, which is course number here and course title, or the attribute here is called course. Okay, good. But what did you notice? Did you notice something here? Look at this. There is some repeated records, right? Repeated record. You see here computing. We'd like to get rid of this. So we'd like to actually computing. We'd like to remove this too, and also database repeated twice. This database and this database. So my table will actually should be only how many records? 1, 2, 3, 4 records. 4 records, not 7 records. Why? Because I would like to remove these repetitive groups, because now it is a table by itself. So we have to actually create a table with course number, because we need the course number to be a primary key. So here this course number a primary key, and this course title is just another attribute for this table. Okay, because course number determine course, so course number now becomes a primary key. Okay. Okay. Now, but how do we relate them? How do we know who is registered in which course? Who is registered in which course? Who is student is registered in which course? How do I know Jones is registered in which course? Or Alan or Richard? So in this case, I have to actually, because the course number here repeated many times, because students are registering on them multiple times. So in this case, I have to actually make the course number here as a foreign key for this student info. So this one course number is a primary key for courses, but it is a foreign key for what? For student info, such that the tables are related together through a foreign key, which is course number. And my data will actually becomes like this. So here, primary key, course number. Now, as you could see, I was able to remove the repeating groups and have only 4 records instead of 7 records, in which course number is a primary key for this table. And here the student number and course number together will be the primary key for this. So it is a composite key. So course number and student number together will determine the rest of the information, and this one will become the detail table, and this one is actually a parent table. So course number here is going to be the foreign key, and it is not a primary key for this, it is foreign key, but the primary key consists of these two together, course number and student number. It is a composite key. Together they determine which student name and the address. And because here Jones is registered in many courses, so you have to have Jones available in 3 different locations, because he is registered in different courses in this one here. So in this case, I can actually I can select the data from students from courses first and see the data in courses. In courses you will see this, and from students info you will see this 7 records. And if you would like to select data from the 2 tables, courses and student info, for example, I'd like to select student number and then course number and course from both tables. So you have to actually write a select statement similar to this one here. Like I can select students info dot course number, student number, student name and course. From what? From the 2 courses, course info and courses. How do I link them together? I link them together through this foreign key primary key relationship, which is course number. So I can say student info dot course number equal courses dot course number, because if I don't provide this wire clause, I will get a Cartesian product in which 4 will be multiplied, 4 records in the courses will be multiplied by 7 here in the students info. I will get 4 times 7, which is 28 records here, 28 records. And you will see everybody is registering in every course. But this wire clause will actually link this primary key in courses to the foreign key in student info, in which you will have 7 records only, in which you selected courses, I mean records from for attributes from both tables, course number and student number, student name and course. You selected course number and course from course table, and you selected student number and student name from from this student info table. So by doing this, now you are actually fixing the issue here that we have seen in this table, because this table has a lot of issues: insert problems, and update problems, and delete problems. So let us first, for example, assume that I would like to insert a new course, English, for example. Let me try this one. Earlier, when I inserted the English in that big table, then you will see that I have to insert a student as well. Otherwise, you will see the data is inconsistent. Here, if I insert into courses values, then 9999, and then English. All right, then you will see that this new record, sorry, let me just select it and then execute it. Courses, not courses. So now let me select and see what happens. You see here I have inserted English course with a course number 9999 without the need to insert any student. So I can keep inserting courses, as many as I want, without registering students in it, because the students table now is a different table. Students info is a different table, completely different from this, but they are relating together through this course number. And then if there is no student registering in this course, then you don't have to worry about that, because now if you executed the previous statement, this one, the previous statement, this one here, you will see that English is not shown. Why? Because there is a student registered in English. There is no English shown here, so that's fine. If there is a student now registered in this course, then you will see this information in this select statement. So as far as this table now is concerned, it includes another record without affecting the other table. This is for the insert anomaly is fixed. About update anomaly. If I would like to update now computing to computer 1, I can just do only one update. Update course via update courses. I mean set course equal set course equal computer 1, computer or computing 1, for example. All right, via course number equal this. All right, so I would like to update courses, this table, to change the course, which is this field, to make it computing 1. This one, I would like to make it computing 1, such that the course number is 92, I mean 01. So how many update I did? Just 1. Now let me see the update. Here now it is computing 1, right? Computing 1. So what do I do if I would like to execute my previous statement? This statement here. What is going to happen? Look at it. You'll see computing 1, computing 1, computing 1 multiple times, right? So you need to actually make the update just once, and you will see the change happened in multiple places. All right, this is one. So this is for the update anomaly is being fixed. The delete anomaly. If one of the students is deleted, for example, I would like to delete Alan. This Alan is gone. His student number is this. So I can say delete from student info where student number equal this. So home DOM, I'd like to delete this student from student info. I'd like to delete this student number, this Alan. He's taking this course, no problem, but I would like to remove him. He's dropped the course, so I'd like to delete him. Okay, here it is, one row deleted. Okay, now did I lose any information about the fact that he's taking computing? I mean, did I remove the fact that there is a course called computing? Here it is. The course computing is there still because I didn't touch this table. I just deleted. I deleted Alan, so Alan is no longer here. He's gone. But the course computing is there, and it is here. It is taken by these two students. So in this situation, I got rid and I fixed the problem for delete anomaly, so that I don't have to lose information if I deleted some records. So I hope this one actually, these examples I gave you made the concept more clearer to you on these examples, and I will see you in another recording. Thank you.